Day 8 of 90. Every network security tool you use, from MAP to Metasploit to Burp Suite, runs on top of sockets. Today I am building 4 security tools from scratch using Python's socket module so we can understand exactly what happens at the transport layer during recon and exploitation. Let us start with TCP Connect scanning. The idea is straightforward. You open a full 3-way handshake to a target port. If the SWNACK comes back and the handshake completes, the port is open. If the connection is refused, the port is closed. If it times out, the port is probably filtered by a firewall. I am using connect_x instead of connect because connect_x returns an error code instead of raising an exception. That matters a lot when you are scanning hundreds of ports in a loop. No exceptions means cleaner code and better performance. To make it fast, I wrap the scan function in concurrent.futures thread pool executor with 50 worker threads. That brings the full 1024 port scan down to about 2 seconds on a local network. Next up, UDP sockets. UDP behaves completely differently from TCP. There is no handshake. You bind to a port with socket.sock_dgram and call requiem to wait for datagrams. Any packet that hits your port is delivered to your application with no connection state, no ordering guarantees, and no built-in authentication. That means your listener needs application layer validation. I am prepending an MD5 hash of the payload to each datagram. The listener computes the hash of the payload portion and compares it to the prefix. If they do not match, the packet gets dropped. This is not cryptographic security. It is integrity checking to filter out random traffic and malformed packets. After you discover open ports, the next step is service identification. Many services announce themselves with a banner when you connect. FTP servers send their version string immediately. SSH does the same. HTTP responds to a head request with server headers. My banner grabber opens a TCP connection, sends an HTTP head request, reads back the first 1024 bytes, and prints whatever comes back. The critical detail here is the timeout. If you connect to a filtered port where the firewall drops packets silently instead of sending RST, your socket will hang forever without a timeout. I set 3 seconds as a reasonable default. That is long enough for most services to respond and short enough to keep the scan moving. Now let us talk about SSL and TLS. Most production services run behind TLS encryption. Python's SSL module wraps a raw TCP socket in an encrypted channel. For security work, this matters in 2 ways. First, you need TLS wrapping to communicate with HTTPS endpoints, SMTPS, IMAPs, and other encrypted services. Second, you can extract certificate details to audit the target. My TLS inspector creates a default SSL context, wraps the connection, and pulls out the certificate. I extract the subject, issuer, cipher suite, protocol version, subject alternative names, and the expiry date. If the certificate expires in less than 30 days, that is a finding in a security assessment. Expired certificates mean broken trust chains and potential man-in-the-middle exposure. Let me cover socket options because they affect tool behavior in ways that are easy to overlook. SO_RUSEADDR lets you rebind a port immediately after your listener closes. Without it, the operating system holds the port in time_wait state for up to 2 minutes. That is a problem if you are restarting a listener repeatedly during testing. TCP_nodelay disables Nagel's algorithm. Nagel buffers small writes and coalesces them into fewer TCP segments. For normal applications that improves efficiency. For exploit delivery, it can break your payload because the target expects data in specific chunk sizes. so_timio and so_sntimio set kernel-level read and write timeouts using struct.pack to create the timeval structure. These operate independently from Python's setTimeout method. That is 4 socket-based security tools built from scratch in one session. A threaded TCP scanner, a UDP integrity listener, a banner grabber, and a TLS certificate inspector. The socket module is the foundation that everything else in network security tooling builds on. Tomorrow on day 9, I will take these socket primitives and build tools that parse protocol-specific responses. See you then.